So basically last time we done OSI model. In OSI model we discuss layers information. In layer information we discuss protocol concept, we discuss segmentation concept, we discuss what is the meaning of packet, we discuss one more topic. Which one? What is the meaning of frames? We discuss what is the meaning of bits, what is the meaning of MAC, what is the meaning of IP. We discuss. Okay. Right now, why we discuss encapsulation and decapsulation topic. For example, this side we are getting a user, and this side we are getting a server. This user and server connected with a wired connection. This one is which one connection, dear? A wired connection. And right now this user say I want to access this server, and this server available with some services. For example, HTTP, HTTPS service, FTP service, DNS service, DSCP service, and multiple services available. So how possible this user can access this server? So today we discuss how to access from this user to this server for services. That means this user generate data and forward on which one side? A server side. Clear? Now, very simple mechanism. So this one is my user and this one is my server, for example, and both are connected with a wired connection. Done. Right now this user having a IP is 192.168.1.1 and MAC address is 000A, and this user this server IP is 192.168.1.2 and MAC address is 000B. Clear? Now, so how communication will possible? This user say this server available with, for example, HTTP service. This server providing a web service. This HTTP service bind with my CCNA.com website. Clear? So that means this user want to access. So this user say, first thing, I'm opening my application and my application name is Google Chrome. So this user say on tab number 1, I will enter CCNA keyword and then enter. This user say that means I am generating some data. I want to reach CCNA. So application layer help to generate traffic and presentation layer responsible inside the data type. Then session layer verify connection. Both side connection is up or down, LAN cable or WAN cable or Wi-Fi communication. If connection is up, then now this user will go to next layer. So basically, if I am using HTTP service, so that means this user say my application generate data, presentation responsible, session layer will be verification. So these three layers work together. And now I will reach on which one layer? Transport layer. On transport layer, this user add with this data, which information? TCP protocol, and session layer and transport work together. Session layer will say in TCP protocol header, I will add a source port and destination port. So source port means this application is fixed application to access web services, or we are getting a multiple service, multiple application. Please tell me, we are having multiple application to access web service or single application only? Gopi, Loyal, we are having a
Yes.
single application or multiple application to access internet services?
Multiple applications.
Multiple application. So right now in this condition, source port is random. I think you already know. So source port is I am using 1025 and destination port is which one service? HTTP 80.
80.
Very good. Now This data reach after transport to which one layer? Network layer. If someone getting confusion, why said on transport layer we at TCP? Because HTTP service work on TCP protocol. Clear? Now, network layer responsible to add with my data one more information. Which one? IP header. In IP header, network layer add a source IP, destination IP, and protocol field. Now, which one is sender? Loyal Gopi. User. So user say my source IP is 192.168.1.1. Which one is destination? 192.168.1.2. And before network layer, which one layer present here? Transport. On transport layer, which protocol we are using? Please tell me. Protocol
TCP.
name? TCP. Done. Now, next layer. This data reach on after network to which one layer?
Data link.
And data link responsible to add with my data. Which one header?
Frame.
Ethernet header. In Ethernet header, I will add source MAC, destination MAC, and type field. So can you please verify which one is source, which one is sender? User. Source MAC is 000A, destination is 000B. And type field means before data link layer or network layer, which one type of protocol we are using? IP. IP is version 4 or version 6? Which one?
4.
IP version
4.
4. So type field we add which one information? We are using IPv4. IP version 4. So data link layer information is successfully add, and now data link to reach on which one layer?
Physical layer.
Physical. On physical layer we add one more header. This data will say I am connected with a which one communication? Wired or wireless? First verify.
Wired.
Wired. In wired connection, we are using Ethernet cable or serial cable?
Ethernet cable.
Ethernet cable. So Ethernet cable having a which one encapsulation type? ARPA or SDLC? Any idea?
What's the question again?
In Ethernet cables, we are using ARPA encapsulation or SDLC encapsulation? We already discussed this thing. So in Ethernet cables, we are using ARPA encapsulation. And then data will be add 010101 and also add time stamp. Time stamp means which time this data will be forward, and data size also. And this data will be transferred from user to server side. Clear? Any doubt, Loyal Gopi?
No.
So which one user, this user say I am encapsulated. Encapsulated means wrap your information. So user will do encapsulation. Now this server will say, okay, I will do decapsulation. How to do decapsulation? This user say I'm receive your data first on wired or wireless. So this server say I'm receive your data with ARPA encapsulation. Data in 0101. I'm getting a timestamp and I'm getting a data size.
So it's exactly vice versa.
Yes. Now this server will verify if you are using a ARPA. So that means your next layer, we are using a which one information? Ethernet header. Yes or no? Okay. Yeah. And now This 01 is machine readable. Now convert into human readable. And this Ethernet header having source MAC and destination MAC. And also have type field. Okay, now. This server will receive which one information? Actually receiving this layer 2 information. So copy this one and paste on Ethernet header. Clear? Now, this server verify destination MAC is my MAC or any other user MAC. Verify. Destination MAC is my MAC or any other user's MAC. My MAC address. Okay. Now, source is 00A. Okay, I'm receiving your data because destination is me. But right now also verify in type field which one is next layer protocol after data link. Which one layer? Network layer, IP header. In IP header, we are using version 4 information. Yes or no? Inside IP header, we are getting which one information? Source IP, destination IP, and protocol. Okay, now this user send server verify. Okay, this one is information I'm receiving. This one, and now server verify which one is destination IP. Loyal Neil Gopi. Destination IP is 1.2. It's my IP or any other server IP. Verify. It's my IP. So accept. And now next layer, which one protocol we are using? TCP. So that means on transport layer, this person will add which one header? Which one header? TCP header. Inside TCP header, one more information available. Source port, destination port. It will define service information. You can say it will define protocol information as well. Yes or no? Now,
that's right.
Same thing verify. This server say, okay, I'm capture this one. And this one is actually user sent. So now can you please verify a destination port number is which one? Which one?
80.
So that means this user want to access which one service from my server?
HTTP.
If this user want to access DNS, so which one destination port add? Destination port will be add. Which one port number?
53.
53. Very good. If this user want to access FTP, so which one port number?
21 or 22. 21 or 20.
Only 21. Very
Only
good.
21.
If this user want to access HTTPS, so which one is destination port?
443.
443. Very good. So basically on transport layer, we can get information. And just mute the mics, dear. And session layer will help to identify the ports number. And this data will reach to now presentation layer and application. These layers work together and you can receive your data. Any doubt for encapsulation or decapsulation? Loyal, Neil, Gopi.
No.
Okay. This thing is true or false? How to verify? So I am having some tools. Okay, this one is Wireshark. In real times, you are using multiple application to capture your data traffic. But right now I'm using Wireshark. This one is a capture your data on wire. Clear? As a real time. So right now I'm connected with Wi-Fi. You can verify. This one is my Wi-Fi connectivity. It's visible. Now I'm capture my Wi-Fi adapter. So where is my Wi-Fi? This one. Double click and this tool will be working now. Okay. Now I'm opening, you can say this web browser, Firefox, and I'm entering a google.com. Done. And then I will access one more thing, Drive. Google Drive. Done. And I just want to access YouTube as well. I want to access which one? You can say Facebook also. Enter. So multiple things we are opening. Yes or no? Now stop this capturing and now verification we do. So multiple packets we are receiving TCP, UDP, TLS. I don't want to capture these things. I'm just capturing one more thing from my device. Go to CMD and write down very simple command IP config to verify what is the my IP address. Now verify. My IP address of wireless adapter is which one, dear? 192.168.0 dot how many? 101. So you can say this user. I'm saying user IP is 192.168.0.101 and user MAC address also I need to verify. So how to get MAC address command? So write down CLS, clear this session, and now IP config /all, enter. Now my wireless LAN adapter MAC address is this one. So copy this one and now paste this side. Done?
Yeah.
Loyal? Okay, now
Yes.
close this one. Now. First thing. So where is this one? Can you please verify one thing? Loyal Neil copy. This information is source IP. This one is my destination IP. This one is protocol. And this one is information about my data payload, how many size and which flag will be enabled. This one. For information. So must be verify source IP is 101. Then we can capture. Okay. So multiple packets we are receiving. So right now verify. Okay, now. So can you please verify? This one is which one? Source IP is which one, Loy? 192.168.0.101. That means it's a me. Okay, one more you can verify. This one also, source IP is 192.168.0. How many? 101. So that means it's a me. So can you please verify TCP double click and now verify Loyal need. So a frame means this first information is layer one. Which one information? Gopi, Loyal, Neil. This first information frame means this one is my layer one information on wire. How many size data we are sending actually? Can you please verify how many size? Size of my data is how many?
54.
54 bytes. If you convert into bits, so this one is bits. Done? Okay. Right now, click on this one and verify. We are using encapsulation type of Ethernet. Encapsulation type of Ethernet. And now arrival time also going. Yes or no? Now next layer. Next layer is actually this one is layer one information. Now next layer is this one. We are using Ethernet header. Ethernet header means layer 2, layer 3, layer 4 or layer 1. Which one? Ethernet header available on which layer? Layer 2. And inside layer 2 header, yeah, inside Ethernet header, source MAC address and destination MAC address and upper layer protocol, how to get type field. And can you please verify source MAC is 287F and last value is F6DT. Now can you please verify my adapter MAC? Both are same or different? Source MAC same, so that means it's a me. And my upper layer, which one protocol we are using?
IPv4.
Very good. That means layer 2 is complete. Now go to layer 3. So this one is my layer 3 and we are using a which one protocol? IPv version 4. Yes or no? Internet Protocol version 4. And now verify one more thing. Inside IPv4 header, multiple information, but I just need to only verify three things. Source IP, destination IP, and protocol field. That means inform upper layer. Right now, how many? Source IP is which one? It's a me or another user. Verify my IP is 101.
Yeah, you are the source.
Yes, and destination is anyone. No worry. And protocol field identify after layer 3, layer 4. Which one protocol we are using? TCP protocol. And TCP protocol number. Protocol number. It's not a port number. Protocol number is 6. Okay. Right now, total size of your data. If I'm saying, brother, this side, hold on. total size data on wired. How many bytes? 54 bytes. Okay, right now. One more thing. Close this one. Header size of IP is how many? Header size of IP, how many? 20 bytes. So 54 minus 20 bytes. So how many remaining, dear? Anyone know? How many?
34.
34 bytes. Okay. And also verify one more thing. Ethernet header size. Last time we discussed Ethernet header size. You can verify in bytes. How many bytes of Ethernet header size total? 14 bytes. Clear? Now 14 bytes also minus from layer 2. So how many bytes remaining?
20.
20 bytes. So very good. Done. Now close this one. And now go to this one is my layer 4. Layer 2, layer 3, layer 1 is done. Now it's my layer 4. So we are using which one protocol? Transmission Control Protocol. That means TCP. In TCP protocol, we are using a source port. We are using destination port. Can you please verify source port is random or reserved? Basically, random port range is 1025 to 65535, and reserved port number range is 1 to 1024. So can you please verify source port is random or reserved?
Random.
And destination port is
Reserve.
reserved. So which one service this user want to access? Can you please tell me? 443.
HTTPS.
HTTPS. Very good. It's a very simple. Done. Okay. Inside TCP, we are getting which one option, dear? Flags. In this flag, we discuss multiple. For example, we discuss fin flag and reset flag, push flag, urgent, sync, acknowledge. This one flags we discuss and multiple available. Verify. Sync, acknowledge, fin, push, reset, urgent point. Okay, which one flag is enable? Enable means 1 or disable means 0. Which one flag is enable? Verify which one flag is enable.
Acknowledge.
Acknowledge. That is the reason TCP flag is acknowledge. Clear? So acknowledge flag is right now 1. Done? Now, one more thing. So TCP header, TCP, IP and Ethernet is clear. Now UDP time. This one. So right now again verify actually in frame we are sending how much data traffic right now? Data size of how much right now? Verify. How many size of data we are sending actually? 318 bytes. Clear? And encapsulation type is Ethernet. Arrival timestamp we are sending IST time zone. Yes or no? Now this one is actually layer 1 information. Frame means layer 1. And after layer 1, we are getting one more layer. Which one, dear? Which one layer? This Ethernet means layer number is 2 or 3 or 4. Which one? Loyal, Neil, Gopi.
2.
2. Okay. In layer 2, verify source MAC, destination MAC, and type field. Type field again we are using IP header. In IP header, basically this one is Internet Protocol version. Source IP is my IP. Destination IP is servers. Okay. And which one protocol we are using on upper layer? Protocol is UDP. Protocol number is 70. Okay, now close this one. Go to layer 4. This layer 4, we are using a which one protocol, dear? UDP. Source port is random or well known?
Random.
And destination port is? If you need to verify this port number, why we use? So hold on. Wikipedia port number. I will show. I know this port number, but I just need to verify for you. Hold on. List of TCP and UDP. And this one is port number. Clear? So find out 8801. For first 443. 443 used for which one service, dear?
HTTPS.
And which one protocol? TCP. Clear? Okay, now one more thing. If I am saying 21, 21 is which one? Port
Yeah.
number 20. Yeah, now verify. 20 and 21 is using for which one services?
HTTP.
FTP. Very good. Now verify 8801. I think it's a Zoom port number. Streaming for streaming. We can say okay. Now verify 8801. Na? So basically, this one is range for. You can say port and number. I think Zoom using 8801. TCP 8801. Okay, we are using. Yeah, verify 8801, 8802. Which one using, dear? Which one using? Zoom client to Zoom meeting for outbound connection. You can verify. Yes or no?
Yeah.
Some port number for reserve for this kind. Okay, now. My payload size, because UDP never get acknowledged, na? So that is the reason. Payload size is how many direct? How much data we are sending actually? 276 byte. This thing is true or false? How to verify, brother? How to verify? So very simple. My data total size is how many? Anyone know? Neil, Loyal, Gopi. Total size of my data, how many? 318 byte. You can verify on layer 1, na? This one is my data size. Ethernet, Ethernet header size is how much? Ethernet header size is 318 minus 14 byte. 318 minus 14 bytes. So how many remaining? 304. Done? This one? Okay. IP header, how much size? Anyone know IP header? How much size? How much size of IP header? 20 bytes. So 20 bytes minus again. So use calculator again. 304 minus 20. So how many? 284. Very good. Now UDP header size is how much byte? Loyal Gopi, any idea? UDP.
8.
TCP is 20 byte, UDP is 8 byte. So minus 8 byte. How much data we are sending actually after minus?
276.
I think this thing is true or false.
It's true.
Here you can verify this kind of information. So right now, this one is your encapsulation or decapsulation process. Clear? And complete data structure we done now. In next session, we start IP networking devices, and then we discuss data flow on device, packet flow. Clear? R process, proxy ARP process, routing table, ARP table, MAC address table. Clear?
Okay.
Any issue, Loyal, Gopi?
No.
Okay. Can we start a batch on